In this video, it's going to be for chapter 12, section 1, and we're going to learn how to find probability and odds. So we have a few definitions we need to cover first. The first one is outcome, and an outcome is a possible result of an experiment. So for example, when you roll a die, there are 6 possible outcomes. You can have the die land on a 1, 2, 3, 4, 5, or 6. When you flip a coin, there are 2 possible outcomes. You can get a head or a tail. So these are the outcomes: head, tails, or when you roll the die or your number cube, it's the numbers 1, 2, 3, 4, 5, or 6. The second definition is an event. An event is an outcome or a collection of outcomes. For example, rolling an even number. Another event could be picking a red card from a deck of cards, like a diamond or a heart. The next definition is sample space, which is the set of all possible outcomes. So again, our sample space for a coin could be head and tail. For the die, it could be the numbers 1, 2, 3, 4, 5, and 6. That's a normal die. Sometimes you'll have a number cube, a problem, and it may say it's a 10-sided number cube. But generally, whenever they say die or number cube, they're talking about the numbers 1 through 6. Let's look at an example. So here it's asking us, or telling us, that we're going to flip the coin twice. They want us to find out how many possible outcomes are in the sample space and to list the possible outcomes. Well, I know when I flip a coin, my 2 outcomes are going to be head or tails. So if I flip it once, I get a head, and then the second time I could flip it again, I could also get a head. But then I could also flip it and get a head with a tail. Now, also when I flip it the first time, instead of getting a head first, I could get a tail, and then I could get a tail the second time, or a tail with a head. The easiest way to figure this out is to take the number of outcomes that are possible in whatever we're doing. So a coin, there's 2 outcomes, and then you're going to multiply that by the number of times that you're doing it. So however many times you're repeating it. So here it said that I am flipping a coin twice. So 2 times 2. So I should end up with 4 possible outcomes, which is what I just listed. Let's try the next one. The next one describes, it says you're flipping a coin and we're also rolling a number cube. So again, when you see the word number cube, think of just rolling a die. So let's go ahead. It says how many possible outcomes are in the sample space and to list them. Well, we know when we flip a coin, we're either going to get a head or we're going to get a tail. And then with that head, when I roll the number cube, know that you can get a 1 with that head. You could get a 2, a 3, a 4, a 5, and a 6. Same thing with the tail. Tail with a 1 on the number cube, tail with a 2 on the number cube, tail with 3, tail with 4, tail with 5, tail with 6. And then if I go back and count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 outcomes. Again, we could use our shortcut. And we know that with the coin, 2 outcomes. And with the die, we have 6. So 2 times 6, I get 12. And that's what I listed, and that's what I counted. So there are 12 possible outcomes in the sample space, and then I listed my possible sample space. Next, we're going to talk about how probability is written. So probability of an event is the chance or likelihood that the event will occur. It's a number between 0 and 1. It can be written as a fraction, a decimal, or a percent. Whenever they're asking you to find the probability of an event, they're going to write the probability of event A is written as P parentheses A. So for example, if I said, what is the probability of rolling ahead or flipping ahead when I'm flipping a coin, I know that there is only one head on the coin out of 2 possible outcomes. So when the probability is 0% or equals 0, then I know it's going to be impossible. It's not going to happen. However, when my probability equals 1, or if you see it as 100%, then you know that's for certain. It's going to happen. And then here in the middle, 0.5 as the decimal. We can also write it as the percent. I could also write it as a fraction. This would be equally likely to either occur or not occur. Again, as a fraction, you would simplify it to 1 over 1. Here would be 0 over 1. And then anything that's trending towards the 0 is going to become more unlikely. Anything getting larger than a half, like 0.75, it might be more likely to happen. Let's look at the next example. Theoretical probability. So theoretical probability is what you think should happen. However, we're also going to talk about experimental probability, and the difference between the two is when you actually do the experiment, like flip the coin, it may not equal your theoretical probability. So theoretical probability can be found when all outcomes are equally likely to occur. Theoretical probability is the number of favorable outcomes over the total number of outcomes. So 2 examples, the simple ones with the coin. Let's say this time, probability of getting a tail. I know that the number of favorable outcomes on my coin, which is the tail, is 1, and the total number of outcomes on the coin, there are 2. It's either a head or a tail. In the example of rolling the dice, so when you roll a die, probability of it landing on the number 2, the number of favorable outcomes, which is the number 2, it only occurs once out of the 6 possible outcomes. If I said same thing, if I'm still talking die here, and I say probability of even, then I could say that there are 3 even numbers on the die, and that would simplify to 1/2. Let's try an example. Now, here it says we're tossing a coin in a number cube. Now, if you recall from the a couple slides ago, we actually listed out the sample space. So let me go ahead and just quickly fill that in. Remember, when we're tossing a coin, we can either get a head or a tail. And then with that head or tail, we can get a 1. With the head, we can get a 2, a 3, a 4, a 5, and a 6. Same thing with the tail. We need to figure out how many outcomes are in our sample space because the bottom of our fraction is always the total. So if they don't ask you to list the sample space, remember we can take the number of outcomes and we can multiply there. So a coin in a number cube, 2 times 6, 12 outcomes. So the probability that the coin shows heads and the number cube shows 5, I'm going to look through my outcomes and find out that it only occurs 1 time. So 1 time out of the total, which is 1/12. The next one is they've given us some information in a chart. And it says, what is the probability that a student chooses a t-shirt with a gold emblem? So here is the gold emblem. And what we're going to do is we need to first figure out how many total we have. So if you go ahead and add, you can either add across or up and down. So I'm going to just go ahead and add up and down. So I have a total of 16 that have gold emblems and a total of 14 that have the silver. So in total, there are 30 different t-shirts. However, they wanted me to find the probability of a gold emblem. So probability of gold, I've already added up this column, so it's 16 over 30. I'm going to simplify, and it's 8 to 15. You should always reduce your fractions. Next, we're going to talk about experimental probability. So experimental probability is based on repeated trials of an experiment. So the experiment has already been done. So for example, you've already flipped your coin or rolled your die, and then you've recorded what happens. So you may flip your coin 10 times, and then you're going to write what happened each time you flipped it, how many times you had got a head and how many times you got a tail. The number of trials is the number of time the experiment is performed. Successes in each trial is when the favorable outcome occurs. So again, number of successes to the total number of trials. And this is going to generally be different than the theoretical probability. Now, sometimes it ends up being the same, but you have to take into consideration that different factors could affect your experimental probability. So let's look at an example of this. So here it says, each section of the spinner shown has the same area. The spinner was spun 20 times. The table shows the results for which color is the experimental probability of stopping on the color the same as the theoretical. So they want us to figure out when is, for which color, blue, red, green, or yellow, which color is the experimental and the theoretical probability the same. So in order to figure this out, I need to find the theoretical probability of each of the colors and the experimental. So let's first do red. So, and I'm going to fill in the theoretical. So let's see, let's do the theoretical probability for each. So for red, there's one red out of the 4 sections. For the blue, there's one blue out of the 4 sections. For the green, same thing, one green section out of the 4. And then lastly, the yellow, and we can see that there's 1 out of 4. Now we're going to do the experimental probability based on the information in our chart. So they told us that the spinner was spun 20 times. Now I could also go back and add up these numbers, but they told me in the problem that it's 20. So let's go through and let's do red. Now all of the denominators are going to be a 20. And then the numerator, I'm going to get that number from the chart. So red is 5. This will simplify to 1/4. Oh wow, look at this. We found our answer right here, and it's going to be A. But let's just go through and double check that there isn't maybe another color. So the blue was 3 from the chart. So 3/20, I can't simplify it. The green is 9. Again, I can't simplify. And then lastly, yellow was 3. So we found it right away, and the color that had the same theoretical as experimental was the red. Now again, remember there are different factors that could influence these results. Maybe this spinner wasn't sitting on a flat table, and then maybe it was more leaning towards the red, and maybe that's why it was the same. Or maybe it was leaning more towards the green. That's why the green had a higher number. So again, there will be different factors that could influence the results when it's experimental. Next, we're going to talk about odds. So the odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. So you have to read the question because it's either going to ask for the odds in favor or the odds against. So when it's odds in favor, you're going to put the number of favorable over the number of unfavorable. So what you're trying for goes on the top and everything else would go on the bottom. So the difference between probability and odds, probability is over the total. So the total is always the denominator, whereas odds is not going to be over the total. You're going to split up the count. So let's try an example. Here, for odds against, so the number of unfavorable and over the number of favorable. So here, same spinner that we did before. Remember, it was broken into equal parts. We had red, we had blue, we had green, and we had yellow. So here, remember for odds now, and it wants odds against, so what you're doing is what you want, or actually what you don't want. So if you go back, so here, what you don't want over what you want. So we wanted green to be on the bottom, and it only occurs once. And then everything else, the red, the blue, and the yellow, there's 3 of those, so 3 to 1. So you could write it as 3:1. You can write it as the fraction or with the word TO. Now it wants us to find the odds in favor of blue. So what we want, and that's the blue, and what we don't want, and that's going to be the red, the green, and the yellow. So what we're going to do is there's 1 blue, and then there's 3 colors that are not blue. So whenever you're doing odds, the number in the fraction should equal the total. So odds against, odds in favor, it doesn't matter. You would add numerator and denominator, and it should equal the total possibilities that you had. So that is it. This is your lesson on odds and probability. It's simple. Tomorrow, the next 2 lessons will be permutations and combinations, and that will finish up chapter 12 that we're going to cover. So go ahead and turn these notes into Canvas, and then you can start working on your homework.